even working, because sometimes they don't. All right, today, this is actually, if you talk to any Algebra 2 students, y'all are learning today the same thing that they learned, or just about yesterday, okay? So, so if you need help, Algebra 2 kids could probably help you as well. So we're going to look at exponential functions. So we haven't done this yet. We've looked at straight lines. So some examples of the equations that we've seen look like this, like y equals 2x, or maybe y equals negative 3x minus 4. See how I just have an x, and that's it. Later in Algebra 2, we'll look at x squared, x to the third. We'll look at all kinds of functions. Today, we're going to look at exponential functions, and notice the word exponent. What do you notice about the x? It's in the what? Exponent. That's how you can tell if it's exponential or not. All right, if the x is in the exponent, it means, okay, one thing it can do is it can grow really fast, right? Like it starts off small and then it just gets bigger and bigger. Doesn't make a straight line, doesn't grow at the same rate. It like starts to double or triple or something, okay, every time. So this one, it shows you that's exponential, well, it doesn't say, but growth, okay? This one is going down, so do y'all know what that one's called? Exponential decay, okay? And then these are just flipped. The reason they're flipped, the blue graphs, is because of what sign right there? The negative. And all this can be done on a graphing calculator. It will make life 10 times easier, okay? If you need to borrow mine while I'm gone, it's in the bottom drawer. Just ask Miss Ashley and then return it. But I only have one. No, I have two, okay? So, anyway, this is what an exponential function looks like. And then here's their equation. It might look like this, like y equals 4 times 2 to the x. Do y'all see how it's a lot different than what we've done? The x is the exponent, exponential function, okay? And then there are some things we'll look at to see if it's growth or decay. Is everybody good so far? Yep. All right, so next, okay, we're going to look at tables. They did not do this part in Algebra 2, so they might not could help you with this. But it wants to know if this is going to make a straight line. Is it going to be linear, or is it going to grow faster and faster and faster, or decrease faster and faster? So is it linear or exponential? All right, so what you're going to look at is the common difference the same? So, like, what's this one going up by? 1. And then it's a little blurry. This one's going up by 1. Now let's check this one. Am I adding or subtracting the same thing? Let's see. If I subtract 2, right? Do I subtract 2 every time? No. Then it's not linear. That's what we've been doing. This one, if you multiply by 3 every time, that means it's exponential, okay? See how there's like a big jump from 3 to 9, and then, wow, it jumps a whole lot, 9 to 27. That's going to be exponential. Okay, let me see. This is what they show y'all right here. It says the table represents exponential because you're multiplying by 3. All right, let's look at this function. It just says y equals 3x. I know you can probably see the answer, but for y equals 3x, first of all, is it linear or exponential? I know you saw it already. Linear. Is x in the exponent? If it's in the exponent, it's exponential. So that one's linear, okay? Let's see. Let's look at these two. What about b? Is that linear or exponential? Part B. Exponential. X is in the exponent. So it's exponential. Okay, that's all you're looking for on those. This one, let's see what the common difference is. That I'm adding 1, adding 1, adding 1. So this is what matters though. What do I add on this one? To get from -1 to 1. I'm adding 2. What do I do from here? 2. Adding 2. Hey, I'm adding 2 every time. So that one is linear. When you're adding.
If you multiply, it's exponential.
If you multiply, it's exponential. Because when you're multiplying, it's making it grow at a faster rate. If you're adding the same amount every time, it's just making a straight line because it's going up the same amount every time. I don't know if that makes sense, but we'll look at graphs in a minute. Okay? So if you add the same amount, it's linear. If you're multiplying by the same amount, it's exponential. If x is in the exponent, it's exponential. Otherwise, what we've seen so far is linear. Are y'all warm now? Are y'all? No, not yet? Okay. So are we good with the first type of problems for tomorrow? Yes, let me see if there's anything on that. I want to say it's not a very long worksheet. There's like 2 of each kind of those. So there's 2 tables and 2 equations. Y'all are good? Okay.
Can you show the other table?
Yeah. So here was this was the equation that's linear. Y equals 3x. If you needed that, that's linear. And then the table is this one. I'll show you leave the answer up there too.
So linear, you just add?
Linear, you add. Exponential, you're multiplying. All right, let's see what we have next. Okay, y'all ready? Everybody's ready? Okay, this one, it's a little, they give us an equation like with this word problem. So it's talking about those flower beetles. Have y'all ever seen those little black bugs that get in flour and like all kinds of stuff? They're, what did I used to call them? You may know the other name for them. I can't think of it. I'll think of it later. Anyway, they're these little bitty black bugs that you'll find in flour or maybe cornmeal or feed, like animal feed and stuff like that. But if it gets into flour, they like multiply like crazy. So they will grow exponentially, and they can just, it's nasty. Like, anyway, like they could just ruin a whole supply of flour. So it says, okay, there's these beetles in this warehouse, and the beetle population is doubling every week. So they give us this equation, and this is what they learned yesterday. Like, this is the starting amount. I don't know that we have to know that yet. We'll eventually get to it. And then this number 2, that means it's going to grow. If that number is bigger than 1, then it means it's going to get bigger. If that number's between 0 and 1, it means it's actually going to decay. I don't know if we have to know that yet, but this means it's doubling. If you're doubling something every day, then it's going to grow rapidly, right? Like if you took your calculator and you say, okay, I started with 1 cent, and every day I doubled it, it wouldn't take long to have like $1 million at all. But you can just type in 1 times 2 times 2 times, and you just keep multiplying times 2, and it grows exponentially. But anyway, this is our equation. All right, they say we always put y equals, they put f of x, that's the same thing. So I'm just going to write y equals 30 times 2 to the x. And it says x is weeks. So how many beetles will there be after 56 days? What's the first problem there? What did I say x is? Weeks. And then this says 56 days. How many weeks is that? 8. Does everybody understand how we got 8? So the first thing I need to do is change that. And it doesn't, sometimes it just gives you the exact number you need. So all you do is you'll say, okay, let me plug in 8. If we left these beetles in the flour for 8 weeks and we didn't take care of it or get rid of the flour, how many beetles would there be? It started out with 30. Okay, that's what that number right there means. Started with 30 beetles. So let me show you how to type it in your calculator. Let's make sure. Some of y'all might have, I'm going to zoom out, different calculators than me. So if I type in 30 times 2, and then I'm going to press this little up arrow. Do y'all see that little up arrow right there? If you have this kind of calculator. and then I'm going to type in 8. So it makes it the exponent. If your calculator is a little different, it might show the up arrow, that's fine. And then if you just left them for 8 weeks, there would then be, it would go from 30 to 7,680 80 beetles. Okay? And that's it. That's your answer. All you do is plug it in your calculator. Is everybody good with that? Yes? Okay. Let's see. Let's try this one. It says you have rabbits and they triple every half year. All right? So, and then they give us a function. Thank goodness you don't even have to write your own function. They say, okay, you start with 20 rabbits and it's tripling. That's why your base is 3. Okay? Then you have your x. And it says x represents a what? Half a year. So how many will there be after 3 years? I'm not plugging in 3. In 3 years, how many times has it been half a year? 6. So that's all you have to do in your calculator. 20 times 3 to the 6. So if you started with 20 rabbits in 3 years,
14,500.
good Lord, 14,580 rabbits. That's all right. I gotta just even make sure that's right, but I think it is. Okay, let's see. Yep, you are right. Okay, it just seemed like a lot. Are we good with those 2 problems? Yeah, so then I think you've got 1, 2 of those on your worksheet, and they give you the equation for those. So far, so good. All right, let's keep going. I'll give y'all a second to write that down. Lakin, you getting all this? I won't be here to answer questions. Okay. All right, we ready? Okay. The next one. All right, this one they want us to graph it, and we have a couple of these. I think this sheet will be easy for y'all tomorrow. Look, and if you get done and you have a lot of time, you can start the next day's work. It doesn't matter to me, or find something else to do. This one, I'm going to show you how to do it without the calculator first. That's the hard way. Then I'll show you how to do it with the calculator. I'm going to put a little graph right here. Okay, so the first thing you're going to do is just pick some numbers for x. Let's just pick a couple. How about -1, 0, and 1? Y'all want to do that? Remember doing this when we had to graph? So then I just have to plug it in. I would just use my calculator, and I would say, okay, I'm going to do 3 times 2 to the -1. Does everybody see what I did there? I just took my -1 and I plugged it in for x. Typed it in my calculator, and it tells me it's 1.5. That's not too bad to graph. I can graph 1.5. All right, now let's plug in 0. I'm just going to scroll up on mine and, and plug in 0. Okay, and then I get 3. So that's that one. And then I'll plug in 1. And I get 6. And then I'm ready to graph. How was that? That's actually not really even that bad either, I don't think. Not too bad. And y'all, it doesn't matter what numbers you pick. I just suggest maybe picking for those 3. Maybe start with a negative, and those 3 are really easy because those are going to keep it small. If you pick any numbers that are much different than those, the numbers get really big really fast, okay, because it's exponential. So if I went -1 and up 1.5, 0 and up 1, 2, 3, and then over 1 and up 1, 2, 3, 4, 5, 6. It's going to look like this. Okay? And it never reaches the x-axis. They call that an asymptote. We'll learn about that in a few years, okay? So it won't ever go below the x-axis on this one, and then it's just going up faster and faster and faster. Okay, the other way to do it, if you just press y equals on your calculator, and you type in 3 times 2 to the x. I'll go back through it in a second. I'll just show y'all first. And then if I graph it, there it is. Okay, so this is what I typed in again. 3 times 2 to the x. And then here it is on my graph. How do I find the points? What do I press for that? Second graph or table. And look, see how I have the same exact points that they do? Okay, so either way is fine. Raise your hand if you're going to use a calculator. Okay, several of y'all prefer calculator. I was just wondering. I'm not sure. It doesn't matter. I'm not sure what you prefer. Okay, and there's going to be a few of these. I'll do one more of these, though, for today. I think there's like 2 or 3 of these on tomorrow's worksheet. Y'all got that? Okay, let's see. Or do y'all need any more of those? Or are we good? No, we're good? Okay, let me see on this one. I'm trying, if I want to do this. Yeah, I guess I'll do this one. Okay. So they give me this function, and then they tell me to graph it. Now, can anybody tell? That's my starting point. So what number do I have to graph at? 100. I have to go up to 100. Do you want to count by ones? No, that'd be miserable. So my starting point is 100. And then, do y'all know if that's going to be growth or decay? Decay. If that number is between 0 and 1, it's decay. Y'all don't even, I don't think, have to know that yet. Okay? But think of it as if, what if it was a half? If you're taking half of something, is it getting smaller or bigger? Smaller. So numbers between 0 and 1 make things smaller. Numbers over 1 are going to make it bigger. Okay? So let's graph this one. And we can, let's see, we can type it in our calculator. We'll go ahead. And I'm going to type in 100 times 0.25 to the x. Okay, and I'm going to graph, and the reason, oh, we do see it pretty good. Okay, I thought we weren't going to see much of it. And it's decay. All right, now we'll check out these values in just a second. Let's look at our table. Second graph, and we've got a lot of little decimals. So you can graph this one of 2 ways. You can either graph decimals or you can count by like 25 or something. What do y'all want to do on your graph? Do you want to graph some of these little decimals, or do you just want to count by bigger numbers? It's totally up to you. We'll just do bigger numbers. Let's just try that. Okay? So if I want to go from 0 to 100, then I might, look, I'll just count by tens. 10, I'm going to say that's 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Is everybody good with that? So that's what, this is one way you could graph a little easier. So you can say 0, 100. There we go.
Could you do hundreds?
Huh?
Could you do hundreds?
Yeah, you could. It's going to be, yeah, you could do that. Because then you would probably graph like -1, 400. That's fine. As long as I can tell what you're graphing by, that would work. 125. So if I go over 1, 10, 25. There we go. That's a little bit better. And then 2 and 6.5. 1, 2, and then I'll just kind of go there. Okay? And it's going that way, and it's going up that way. Is everybody good with that? And then if you look at their graph, we just can't, it doesn't look exactly like it because mine's only going up to 10 right here, and that one's going to 100. Do I need to do another one like that? We're good? Did anybody want me to graph it using the decimals instead? No? Okay, y'all just bored and done with it, huh? All right, let's see if I have anything else. If I have this one. That's a graph, that's a graph. I think, let's see. This is not on your paper, but I'll go ahead and go over this. It's not on your paper for tomorrow, but it's in the book, so we'll just finish it. Okay, so they give us two different types of problems. They want us to see when is, are y'all warm yet? Okay. When is this going to be equal to this? This, you would have to use a graphing calculator. That's why it's not on tomorrow's worksheet. I don't think it's on your test. But this will give you a head start for Algebra 2. So we're going to go over it. If you have a calculator, I want you to press Y equals. Oops, wrong one. Okay? And in the first Y equals, I want us to type in this. Let's type in 2 to the x. That's just a function where you're doubling something. And then in the second equation, what would I type in?
0.5x plus
This. Then when I graph it, y'all, I'm going to see where they equal, where they cross. Okay? So let me type in 0.5x plus 2. Okay? And then I'll press graph. Did I press it right? Hold on. I was about to say, I didn't think I... 0.5x plus 2. There it is. Okay, how many times do those graphs cross? They cross twice. So how many answers do I have? 2. So it's just this x value and about that x value. Okay, so do y'all know how to find those? So did you put to the x? No, you put 2x. It's got to be 2, and then you got to press that up button to the x.
How do you do that? Like make it x.
Okay, so you press that up button, and then here's the x button.
I'll show you one.
That's because your window is crazy. So press zoom 6. Okay. Did I not press zoom 6? Let me go back to your graph. Zoom 6.
Hey, high school baseball players, I need to meet with you right after break in the auditorium. Right after break in the auditorium.
Okay. Now, real quick, I'm just going to teach y'all how to find these. Okay, which you could probably guess. I'm guessing it's close to 2 and 1, 2, 3, -4. That's what I'm thinking. But let's find them. On your calculator, there's a little button. Okay, and you can find where they intersect, where they cross. Okay, so if you press second trace and then number 5. Have we done this? Yeah, we did this with all the systems of equations. Okay, now here's the thing. There's 2 answers, so let me just press enter. Enter, enter, and that gives us the first one. I was wrong. I guessed that it was 2. What did it tell me it was? Look at your x value. It's 1.4. Okay? So I would put 1.4. How many decimals did they go to? They did. They just put 1.4, whatever. Okay. Then, now I need to find the other one. So let's do that again. Let's see how it went to the one on the right? Everybody see that? So if I press second trace and I go back down to intersect, before I press anything, I'm going to go to the left. See how I'm taking it over here? Because I want to tell it, let's go find this one. And I press enter, enter, enter. And what does it tell me this one is? Negative 3.8. Okay, again, you're not going to be tested on this, but if you understand this, you are very ahead for Algebra 2. This is like the kind of stuff that we'll be doing in Algebra 2, okay? So, I just wanted to introduce all that to you. Do I need to go over any of that again? No? Okay. All right. I think, look, I'm done. That's everything. Is there anybody that wants me to go over anything? Because after, I won't be here. So...